So good morning, folks. So I'm experimenting on, like, I'm taking flats right now, like sky flats. So I put like a t-shirt in front of it and taking pictures. So I have to take flats for each narrowband filter. So right now I'm experimenting with flats as well as with some narrowband filters and see how RASA will turn out to be. RASA works on f2.2. So basically it is not f10, like focal length of 10. So you don't need to install like Hyperstar kind of setup in the front anymore. There is kind of, you can think of, there is a Hyperstar already built in. So typical Celestron 11 inches Smith's Cassegrain telescope will be of a focal length of f10. So when you put a Hyperstar on it, you will bring it to f2. So actually you are much faster and you are further away from the object, so you get a larger field of view. At the same time, you are going to take pictures much faster too. Same thing here, you are doing f2.2 and it built in with f2.2, so you are going to take pictures with f2.2, so it's going to be pretty fast. So you have to use the right narrowband filters to do that. Right now I'm experimenting with those narrowband filters there. So let me explain you about the CGXL-Mount. So I wanted to talk about the CGXL-Mount. I think I'm using the CGXL-Mount for the last couple of weeks. I think I'm getting to know this mount well. This mount, first thing first, it's very heavy. It's huge. It's like, it carries like 75 pounds, but the mount head is 50 pounds. And the weights are like 44 pounds. So it's like a 50 pounds, 50 pounds and 50 pounds. Just right here, you're talking like 150 pounds. So if you put a telescope on it, it becomes like 200 pound size. So you have to be careful and you have to plan your logistics around to make sure how you are going to move this around. I think that is the key when you're buying this mount. It carries excellent weight, but you have to plan the logistics for the weight. That is actually your problem number one. You can take this mount like as a grab and go kind of a mount. The reason is it has like 3 screws that you need to, Allen wrench you have to use and take them out, and then you have to lift the mount head. And taking the mount head inside or wherever you want it to go, and taking these 22 pound weights, 2 of them out, and then folding the tripod legs, that stuff takes time, so you have to plan around it. So this is not a true grab and go mount, I would say. I would call this like you can put this in a home observatory kind of thing, or like do what I'm doing, which is put it on the wheels, bring it outside, put it back inside. I think that is safe. One thing to remember is you wanted to the RA axis and the deck, these 2 clutches, you need to unlock them and then move it around. So when you are moving the mount, you are not locking the gears because you don't want to put pressure on them. So leave them unlocked and then, you know, slowly move outside. I think it's a lot safer. If you lock this once, you are engaging the gear and you are moving the mount too. I don't know if it's a good idea. So after putting the telescope, you need to lock these. So you have to take the telescope first out if you are planning to like take this mount inside. I think that's what I'm doing right now. So before you bring your mount, make sure that these are open, like, and you have enough space here, because when you carry the weight, you can't do this with one hand. Have at least one more person helping you when you are moving the mount outside, or when you are keeping the telescope on the mount, or taking the telescope off the mount. So doing it all by yourself, I don't think it's a good idea because of the weights that it is you're dealing can see behind me in the telescope, it started taking pictures. It's doing good guiding, looks like it's doing like at 0.4, and also it is doing good focusing. It's staying at that focus. It's at like 1.96. It's manual focus, but the focus is okay. It stayed on. Okay, I got my files finally into Pixinsight. I ended up taking the Pleiades, the Seven Sisters M45. So right now, I wanted to do the first step in Pixinsight. I wanted to do is to do the blink function. So I think I took like 100 pictures, 30 seconds each. Some of them I have to throw away, but anyway, let's see. So 30 seconds each. This won't take too long. Like, it just opens the files and it gives you like a preview kind of thing. So you have to kind of quickly browse through the files. That's what the blink function does. I started liking the blink function quite a bit because some of the stuff that I'm seeing, like if a satellite is moving or something, sometimes Pixinsight doesn't really capture that. I don't know, maybe I have to change some settings and all. So if I go through, also sometimes the clouds too. So if I see some problem with the picture because of the haze or clouds, I think just by doing a quick glance at it might actually help you whether you wanted to retain the picture or not. When you take really short exposures, you could afford to lose some of the frames, but if you are truly taking like 5-minute frames, I don't think you would be making a quick decision whether to keep it or not. Chances are you really wanted to keep those files. The file that you don't want, all you have to do is there is a little button there. Press that button, move to some whatever trash folder, and then close that image. That little red box is closing the image, and you can move the file, and once you move the file, close the image so that it doesn't stay in your list of things here. So in the main folder where you saw your images, all you will see would be just the good images. That's all it is. Okay, the next step I wanted to perform in Pixinsight would be to run a process in the script called subframe selector. So what I'm looking in the subframe selector is taking the pictures that were identified from the blink as the good ones, and then like calculate like FWHM score, and if the score is either too high or too low, remove that score, remove those pictures. So right now I completed clicking on that measure, which gives me that plot, and then when you click on that measure and it gives you this plot, all you have to do is click on those little bubbles or like dots, and the ones that you are selecting that are kind of out of focus, right? You can do on various indicators. FWHM is one of them. You can try the other ones too. I mean, it doesn't matter really to go too picky, but if you have several frames, you wanted to reduce your processing time by keeping really good pictures, I think you can go by these indicators and see if something is too much off, right? Select that. So you know if it is extreme, obviously it's not really good. So you wanted to take that picture out. There is a little button there called output, and in that output you can specify like which folder you wanted to like move the bad files, right? So in the output directory, if you say that I just wanted to don't touch or don't touch the approved, but move the ones that I selected into some kind of a trash folder, and the system will do that. So right now I wanted to integrate all my flats, like that's my step number one. Like that I wanted to integrate all my dark files and all my bias files, right? I took like 50 of each roughly, so I'm integrating them. So when you select the files that you wanted to integrate, now in the pixel rejection, I don't think you wanted to select any, so you're going to pretty much leave the defaults by not selecting any rejection criteria that you would normally select in case of a light frame. If it is a light frame, when you do pixel rejection, typically I would select something called Windsorized Sigma clipping. I think that option I would not select if I'm doing like flats, bias, or darks integration. So I just completed my flats integration. You can see my flat, how it looks like. I take dark flats. So once the image integration is complete, I change the label of the file, and also I save the file to my hard disk in a folder called like master files. I'll save it manually in that XILF format, if I'm right. Once I complete the saving of that file, so I'm creating a directory called master files directory. You don't want to save as a JPEG. This format here. Okay, the options that comes up there, you can just leave them on. You don't need to touch them. You don't need this file. The next thing to do is to integrate dark files and bias files the same way and save. Completed integration of our flats, bias, and dark frames, we can actually now start working on our light frames. The first step that you wanted to check is to calibrate one of your light frames. So let's say you pick 96, image 96, and select image calibration in the all processes. Create like a new output folder whatever the output folder where you want the final files to be. And this is my 6th iteration. You can see that. I selected my master bias file, my master dark file, and my master flat file. You have to select in the appropriate buckets. There is a little button there called Calibrate under each one of them. It's a pretty long explanation to explain. Like, it kind of does the minus thing. So the flats will have a, you need to do flats minus darks minus bias. So in the dark you should not have a bias, in the flat you should not have a dark. It's kind of difficult to explain, but that's what it is. But anyway, you select those, look at your calibration frame, see how it looks like, and if it looks good, like this is the original frame, like frame 96, and what I'm looking at is I wanted to make sure that vignetting in the corners is gone. So if I run this one, I don't want to see any vignetting in the corners. That's what I'm working on. So if this works, I could actually bring all my files and calibrate all the files. So it creates that file in this directory wherever we said output directory is. Now this is my calibrated file. If you compare the original file with this file, you would pretty much see like a nice flat image, kind of, all the vignetting is gone. By the way, I just select the dark flats. My flats are like somewhere in the 500 to 700 kind of ADU, 500 to 700 ADU. It's pretty dark. The reason for that was I need to tell my system my dark is dark and my light is light, because my light is extremely bright in the middle and the dark is like really dark in the corners because of the vignetting. So I tend to take dark flats almost, meaning almost like no light at all. You're kind of capturing at that level. Okay, that's like for another day discussion, but anyway, I take flats that are ADU around 500 to 700 to make sure I capture everything that I need to capture. So now I think this file looks good. So what I'll do is I'll delete the newly created file that I did, and then I will select all my light frames there. So the first step is done as part of our image post-processing, which is the image calibration, right? Because I used one-shot color, I have to select debayer as my second process. So debayer process will debayer it, like remove the Bayer matrix, which is the RGGB, like red, green, green and blue matrix, and then create like the color file. So right now you are seeing black and white files. Those files gets decoded back into the RGGB pattern so that you will actually start seeing the color once the debayer process is complete. I think I specified all my calibration files at this point and then included them in the debayer. Those are all defaults. And then you run the process of debayering. Debayering typically takes like somewhere around like 5 minutes range for 100 files. It doesn't take a whole lot of time, but once the debayer is done, you should see kind of a color file that comes your way. So let's pick one of them and see if it shows the colors that we need. So this is the background. So let's do a little automatic background extracts and see how a single picture is going to look like in the color, the Pleiades. It came out okay. I'm not terrifically satisfied, but it came out really better than I expected, I would say. It's not fantastic picture yet, but I think it came out decent enough. So it's a good flat field around, no vignetting. You can see the blues, the nebulosity around those stars. These are called Seven Sisters for a reason. Looks good. I'm just enjoying my picture. Yeah, it's a single frame of 30 seconds. Lightly, I have some little bit of that chrominance noise kind of thing. You see that like color kind of background little bit in the back, like all those. If we do a process called MMT, which is multi-scale Meridian transformation, I think that stuff will go away. All those diffraction spikes caused by my RASA, the central obstruction, but it looks kind of cool. You see all that those chrominance noise should go away from the picture once we post-process it. Okay, so the next step after the debayer is done is to go into what we call star alignment. Star alignment is going to create, it takes our debayer files and then creates registered files. So you start from the calibration, then you go to debayer, then you go to the registration process, which is nothing but the star alignment. For star alignment, you have to give a reference image. So ideally, you need to pick the best image that you have as a reference image. But usually I select like the first picture or the very last picture, depends on the day, because I wanted stars to be aligned in certain way. The alignment is not based on the quality of the picture. The alignment is based on the position of the picture and the framing of the picture. That's what I'm aiming for. So I typically select either the last one or the first one, depends on how the framing turned out to be. So in this case, I selected the very first one from that list of debayered files and select all my files. Reason I'm going so slow is I received so much feedback saying that don't run your process so quickly, we are not following it. So I kind of slowed down quite a bit, and then I started almost showing you live in terms of how much time it takes. The only time you're seeing fast forward is when a process is running behind the scenes, where it takes too long to wait. Like for example, right now, star alignment takes like 6 to 7 minutes. So at that time, I'm actually pausing it so that it moves on. So it's still running my star alignment process. This stuff will create what we call registered files. That's what we want. Okay, the registration is almost done. So what this means is all my files are now calibrated, debayered, and registered. The fourth step that I need to perform is called image integration. This image integration will combine all those 100 plus files into a single file. The only difference between integrating your flats or bias files or dark files versus integrating the light files would be, you would give a pixel resection kind of algorithm in this list. So I would select this winsorized sigma clipping as my process, and it changes whatever that is needed in the rejection 2 and rejection 3. I don't change anything else. So now This process will create an integration file, and the file is on your screen. So it's not putting the file like in an output directory. So whatever the file that you get will be on the screen itself, and you need to make sure you save that file. Otherwise, you have to run this process again to create that integration file. Right? It ran successfully right now. It creates that rejection high, rejection low kind of files as well, besides the final integration file. So these are the pixels that got rejected from the dark files, the bias files, and the flat files, some alignment, and then I got this file. I have some vignetting in the corners, in the left hand side, in the bottom and the top, and I'm guessing if I run the proper automatic background, I should be able to remove most of it. It does take time. This ABE, which is the automatic background, and the dynamic background, you just need to look at whichever file is better. Right now, I think the ABE file is no good. So I really don't want to use the automatic background to actually do this one. I wanted to go and do dynamic background. So in case of dynamic background, the dots that you are creating, there is a sample generation where you click the model, and you could increase the tolerance a little bit, and then when you generate, like basically the number of points that you need to put it on the file for generating it, you could change that number higher or lower. You can't go too high because your machine cannot process at all, so be careful. But you could go reasonably, like increase. So that's the kind of model it created. I do wanted the top, left hand side and the bottom right hand side vignetting is done. So if I try to select them, it creates that red dots rather than the white dots. What that means is my tolerance level is not high enough. So if I increase the tolerance level, click on regenerate, I get a better file. Let me work on. So I couldn't get rid of only on one side, the right hand side, a little bit of vignetting. I just don't want to, fight with it. So I'm doing a cropping called dynamic crop. I went into all processes, selected that. Dynamic crop is pretty simple. When you click the button on the right hand side lower corner of dynamic crop, it gives you a little kind of a transparent image like this one. Place it where you want it to, like kind of drag and move it around, put it in the right place. And if you think that's what you want, click on that little tick mark, which will kind of cut the picture the way you wanted it. So I would usually take time to do this one, because this one usually turns out to be pretty good actually once it's all done. So you don't want to lose way too much, same time you don't want to keep too much. So you kind of need to balance out. And typically you wanted to do this before you do the curves transformation, because the extreme colors in the corners actually might mess up your curves transformation. So you typically wanted to do that before you perform the next step. So the next step that I wanted to do is go into what we call curves transformation. Usually I do this like once or twice. I didn't like the cropped picture at all. So what I'm thinking is to close this picture off and I can do a photometric color calibration. So I closed my cropped picture and I went into photometric to see if it improves anything. So to do photometric, you need to open the photometric color calibration process and open one of your source images and click on acquire image. So this typically brings all the coordinates that you need, and drag that photometric on top of the image. That will do three things actually. It does background neutralization, it does the color calibration, and it does what we call multi-scale median transform to some level. And it's doing all that. Once it's done, I'm thinking the vignetting might go away. If it is not, then I'll crop it anyway. That's the plan. It does take a little longer once it's like maybe 5 minutes or so. And once it is done, you can close the remaining windows. So it completed the photometric color calibration. You can close those windows. So this is the file. You may have to do that nuclear button on the screen transfer function just to open up. It didn't actually fix any vignetting. Obviously, I'm not expecting a whole lot, but chances are it might have done a good color calibration and background neutralization. So the choice that now I have is to do the dynamic crop again and get rid of some of that unwanted stuff. So I did a dynamic crop. You saw the process before. So the picture looks great edge to edge. I don't have a problem with it, but I think we could increase the color saturation a little bit. I go into curves transformation. Typically I click on that saturate button, increase the saturation a little bit in the middle. It'll boost up the color, whatever the color it has, so that it shows up a little bit stronger blue rather than a sky blue. You don't want to overdo this one, but I think by saturating it a little bit, you could bring a good color. And if you neutralize the background as well on top of it, which is like, you reset the button there in the corner, and then these color changes here I would not recommend at all. I'm just testing it, but I generally would not touch these because it doesn't look natural at all. I don't like it. So if I go into RGBK, I could bring it down the background a little bit, but if you bring down way too much, you lose the nebulosity. So usually what I do is I put a point on the curve and I change the numbers manually, because like my hand gesture is not tiny enough for me to just reduce what I want. So the dot on the curve will help me, and I know it is going down, and I kind of give a little lesser number than the one on the top. And you could see the picture yourself by reducing maybe 100 points and see if that's what you want. Anytime you increase this, you are kind of reducing the nebulosity. You don't want to do that, because the whole point of the picture, taking the picture, is to show the nebulosity, right? So try to not overdo the background too dark, because you are losing details in the picture sometime. Anyway, so that's that part. I mean, this is more of a taste at this point. So if you wanted to do something additional, I didn't end up doing anything else. I mean, these are the main two things I did, which is I saturated a little bit, fixed the background. So I stopped working on the curves transformation. I went into this multi-scale median transformation, also called MMT. You can see my numbers there. So you see that chrominance noise in the back. That's what I'm trying to attack. So the process is running right now, once the process is done, I should be able to see the reduced chrominance noise. I wanted to compare it like before and after. And if the chrominance noise is almost gone with that kind of numbers that I provided there. So right now, if you see, this is what is there, and after I ran that process, that's what it is. So it's pretty good actually in terms of how that process came out to be. So here is my final file. I hope you learned something and I hope you liked it. Please don't forget to subscribe. Thanks for watching.